Hello children, we have already done three inverse functions: trigonometric inverse function, sine inverse x, cos inverse x, tan inverse x, and we explained to you clearly that for presenting the function as a for presenting a curve as a function, or converting the presenting the curve as a function, we restricted the domain of sine, cos, and tan. Sine's domain was restricted from minus pi by 2 to pi by 2. In cos, it was restricted to 0 to pi, and in tan, it was restricted from minus pi by 2 to pi. Now we are going to do about cot. First of all, I'll define and plot cot. We've already done that in detail, but as I told you that whenever we are going to start inverse, we are going to give you an idea that how cot is uh, plotted and what its significance is. Cot x is cos x upon sin x. So there are certain things which we told you in the beginning very clearly. If sin x is 0, which is in the denominator, sin x is 0, it will make cot x not defined. Not defined. So sin x is 0 where? Where x is n pi. X is n pi. Either it should be sin 0 or sin pi or sin 2 pi or sin 3 pi. At all these points, sin x is not defined. Sin x is not defined. All these points sin x will not be, cot x will not be defined because sin x is this value. Sin x will be 0, so cot x cannot be defined. And if sin x is 1 and cos x is 0, at what point? At x is equal to 2n plus 1 pi by 2. So at odd multiples of pi by 2, the value of cot x will be 0. The value of cot x will be 0. It will be defined. So how we used to draw the graph, if you look at the graph of cot x, I'll just draw it for you. I'll draw only one interval. I would say the one, what you call it, period. Like if I take it 0, I take it pi by 2, pi, 3 pi by 2, 2 pi. I take it minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Now we saw that cot was not defined when it was sine was 0. That means at pi it is not defined. At 0 it is not defined. It is not defined at 0. The curve is something like this. The curve is something like this. It is passing through pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2, because at this point cos 0 is 1. Sorry, at this point, yes, cos x is 0 because at odd multiple of pi by 2 cos is 1, cos is 0 and sine is 1. So it is passing through this point. It is passing through this point because it is becoming 0. This is the curve of the cot. This is the curve of the cot. For the cot also, we will take, when we are going to find the inverse of cot x, for inverse domain of cot is restricted from 0 to pi. 0 to pi. We restrict it from 0 to pi. We restrict it from 0 to pi. And how are we going to draw this graph? This is x dash O. This is pi by 2. This is pi. It is 0. You can say it is to be 0. And the curve of the 10x cot x is just the reverse, like this. This is y is equal to cot inverse x. What does it show? It's just the reverse of the smile, extended smile for 10 inverse. Similarly, it is cot inverse. The only difference is that here the curve is between 0 and pi. There it was minus pi by 2 to pi. It is totally above the x-axis, totally above the x-axis. While as in 10 inverse x, it was half above the x-axis, half below the x-axis. Half above the x-axis, half below the x-axis. But here the complete graph is above x-axis. Now let us see what is the domain. Again, domain of this function is exactly the same as for 10 inverse x, set of real numbers, or it could be minus infinity to plus infinity. Range is where is the range? 0 to pi, 0 to pi, 0 to pi,